This is a data representation question about images. So comes from the AQA Practice Paper. So we know that images is very likely to be in this year's exam because they've said it is in there in the pre-release type material. So we've got a 10 by 10 pixel black and white image. So pixel, short for picture element. I could write it, it'd be better. Picture element. So the smallest representable bit of information on an image. This is black and white, so that means we've only got zeros and ones. The row that we're interested in for this question, so it's the binary coding for row 5. It says that 0 is for black and 1 is for white. So the row that we're interested in is row 5, which I've highlighted. So if 1 is for white, we have 2 ones and a 0 and 3 ones in the middle, and then another 0 and then 3 more ones. So all we have to do is write that in. 1 1 0 1 1 1 0 1 1 1. You don't have to put the other bits on the ones. 1 1 0 1 1 1 0 1 1 1. So that one's fairly straightforward, I hope, for 1 point. The only thing we have to make sure we know is that 0 in this case is for black and 1 for white. Okay, so if we change the image on this one and we make it an image with 64 different colors, then we need to calculate the amount of memory that would be needed to store the image in bytes. So if we've got a binary pattern like this one, then we've got here 1 2 3 4 5 6 bits. If we had the next one, it would be 64. 64 different colors is what we need, so that means the one down from that is always going to be where we're at. So that's because this adds up to 63, but we've also got the case where we've got 0, which means we have 64. So we need to calculate the amount. So we've got a 10 by 10, and now we know that we need 6 bits for that. So 10 times 10 times 6. So we've got the right amount there. 10 by 10 by 6 is 600, and these are bits. But it says we need to do it in bytes. So 600 divided by 8. If we divide that by 8, we should get 75. So the final answer is 75 bytes. So if you didn't quite get 75 bytes in this, you'd still get a mark for writing down that we needed to do 10 times 10. You'd have got a mark for multiplying by 6 and a mark for dividing by 8 here. So always remember, if we've got a number of colors, 64 colors in this case, it's going to be the one down from that in our binary patterns in order to accommodate that number of colors. Well, they might go in between sometimes, and they might say, well, what if there's 12 colors? So for 12 colors, we're going to need 4 bits for 12 colors. In 4 bits, we could do up to 16 colors. So 8 plus 4 plus 2 plus 1 is 15 plus the 0. We could do up to 16 colors, but 12 would be fine accommodated in that area. So if they do ask you that, just think about how many numbers can I get into my binary pattern.